Hello students, and this today's session is going to be on chemistry, and I'm going to start with a topic called stoichiometry in chemistry. And the stoichiometry is a topic which the students of this IGCSE curriculum, they encounter it for the first time in the 10th grade, okay, during the school studies, and further in the IB when they go for the 11th, 12th, okay, there also they get the same topic, stoichiometry. So this is a general video, and I'm going to make this video not only in one particular part, but maybe it will be in many parts. And I'm going to start today so that you understand this stoichiometry right from the scratch. Okay. So first of all, stoichiometry is a word which can be split into stoichio and metry. Okay. Stoichio means, in Greek language, it means elements, and metry means measuring. Putting these two words together, stoichiometry together, means it's a science of calculating the quantities. Yeah, of course, these are the chemical quantities which you will find in the chemical reactions, okay, in the form of chemical equations. So this is a science of calculation of quantities in the chemical reaction or chemical equation. Okay, so basically these quantities, are measured, okay, and calculated. For example, reactants. If you know the amount of reactants, okay, you can predict or you can calculate the amount of product that can be formed. Okay. See, you have chemical reactions, and chemical reactions can be expressed in the form of chemical equations. In a chemical equation, you have two sides, left hand side and the right hand side. So they are separated by arrow mark. So whatever is there on the left hand side of the arrow mark, those are the reactants, and whatever you see on the right hand side are the products. Okay, so basically if you have some knowledge about the reactants, the quantity, amount of reactants, okay, you can predict what will be the product, and the reverse can also be done. Okay, so even the reactant required can be predicted, okay, in amount, okay, to get a desired amount of product, right? So this is basically what is known as stoichiometry. Okay, so in short, again I'll tell you, stoichiometry is that branch of chemistry in which you are going to study to calculate, you are going to learn to calculate how much reactant given will give you how much amount of product, or you can also predict the amount of reactant needed to get a fixed amount of product. Okay, so either way you can do. Okay, so this is what is basically the meaning of stoichiometry in chemistry. And for this, okay, what you essentially require is something called a balanced chemical equation. Okay, so for this essentially you need a balanced chemical equation, right? I'll give you an example if you want. Okay, for the sake of understanding. Okay, suppose you have a balanced chemical reaction, okay, shown by this equation. Say calcium carbonate CaCO3 reacting with two molecules of hydrochloric acid, okay, giving you calcium chloride, that is CaCl2, plus water molecule H2O plus CO2. Okay, CO2. Now this you can see is a balanced chemical equation, right? Calcium over here is 1 on the left hand side, here also it is 1. Carbon over here on the left hand side, you can see again there is 1. Here also you can see it is 1. Oxygen on the left hand side, you can see there are 3 atoms of oxygen. Here also you can see 2 and 1, 3. Okay. Then coming to hydrogen, you have 2 atoms of hydrogen over here on the left hand side, and on the right hand side also you have 2 atoms of hydrogen. Then chlorine, you have 2 chlorine atoms on the left hand side, and the right hand side also you have 2 chlorine. So this is a balanced chemical equation, right? I'm trying to make you understand what stoichiometry really helps you and how it helps you. Now suppose this is a balanced chemical equation given to you, and somebody says that, okay, if they tell you that suppose 10 gram of this calcium carbonate is taken. So these are the reactants on the left hand side. So this is one reactant, this is another reactant. So suppose 10 gram of calcium carbonate is taken, then how much amount of this particular carbon dioxide is obtained. Okay. Now this type of questions or this type of calculations, can be done with the help of this stoichiometry. Okay, so this is the example which I gave you to understand what actually stoichiometry means. Is that clear? That way you can have some other chemical equation also with you, a balanced one of course, and there also suppose the question may be of a different type. They may ask you how much reactant is needed to get a desired amount of the product on the right hand side. Okay, so such questions can also be asked, right? This question only can be twisted like how much calcium carbonate, how much amount of calcium carbonate is needed. This type of question can also be asked, right? How much amount of calcium how much calcium carbonate is needed, okay, that is the mass, okay, in grams, to obtain, okay, certain say 56 grams of carbon dioxide, something like that, okay, or 50, this is gas, okay, so it can be in volume, okay, so it can be how much, okay, gram also can be there, or you can say this type of question also can be there. Okay, to obtain say 5 ml, okay, 5 ml of carbon dioxide, something like that. Okay, so both this type of questions are telling you that stoichiometry is something which will help you in getting answers to such questions, right? So basically, what is the meaning of stoichiometry? I try to explain you in my own way, giving this example. Okay, now it's not that easy, to go into deep and study so many things right from the scrap. Okay, so as I told you, any chemical reaction in general, this was an example I gave you, but in general, a chemical equation can be like small a followed by capital A, and a small b followed by capital B, arrow mark, small c followed by capital C plus small d followed by capital D. This is suppose a balanced chemical equation. Now in this equation, these capital letters, A, B, C, and D. So A and B are representing reactants, okay, and C and D, capital C and capital D, are representing products, right? Like in the case above, okay, A can be calcium carbonate, okay, B can be hydrochloric acid HCl, C can be calcium chloride, and D can be H2O. Here you have carbon dioxide also, you have three products, but here I have given you an example where two products you can get C and D. Okay, this small a, small b, small c, and small d, these are in the form of some numbers. Okay, it can be 1, 2, 3, 4, any natural numbers. It can be even fraction, right? Half, okay, and 3 by 2, something like that. Even fraction is possible, but mostly it is a whole number, okay, and positive numbers, right? So A, B, C, D, these are known as something called stoichiometric coefficients. Okay, these are known as stoichiometric coefficients. Now, further when we proceed, we are going to make use of these stoichiometric coefficients for our calculations. So these are what are known as stoichiometric coefficients. Okay. Okay. Now, quantities. Okay. Quantities. That is the reactant and the products. Okay. Quantities can be in terms of, quantities means any reactant or any product that can be in terms of, say, moles, or it can be in terms of mass, or it can be in terms of volume, or it can be in terms of concentration. Okay, moles, mass, volume, concentration. In this question, where I tried to explain you the meaning of stoichiometry, I asked the question, if 10 gram, can you see here? If 10 gram of calcium carbonate is given to you, so here this calcium carbonate is one of the reactant, that quantity, and it is measured in terms of grams, in terms of mass. So it is a mass. Mass is given for calcium carbonate. And the product carbon dioxide will be obtained, say here it is given in terms of volume, 5 ml of carbon dioxide. Okay. So calcium carbonate is a reactant, hydrochloric acid is another reactant, calcium chloride, water, and carbon dioxide, and what is this? Yeah, carbon dioxide. These are the products. Okay. So these reactants or products can be expressed either in moles or in mass or volume or concentration. Okay. So now, before we come to actual stoichiometry, okay, now you must have got an idea like what stoichiometry is, and this was a very rough idea that I gave you. Okay, when you go into detail, you will see there are so many things that you have to be familiar with. Okay, so, and as I told you, this particular topic I'm going to prepare not from the point of view of a particular curriculum, not for IGCSE, not for IBDP. Okay, so there's no level. In general, stoichiometry as a topic in chemistry, how you have to deal with, whether it is in the school level or whether it is in the IB level. Okay, that is higher grade. Okay, you should know from the scrap everything, and that is what I'm trying to do in this series of videos that I'm going to prepare. This being my first video on stoichiometry, remember that. So I've just started with a faint idea. Okay, so now let me tell you, before taking a deep dive into this topic, okay, you should be you should know certain basic concepts of chemistry. Okay, so the basic concepts okay, which many of you must be aware of, but then you should now try to understand these concepts very nicely, and there should be clarity of these concepts, and later on we are going to connect these concepts to build up this topic. Okay, so I'm going to explain you concept wise, different concept I'll be explaining you separately, and wherever the concepts are being connected, I'll let you know how they are getting connected, and how this stoichiometry as a topic is going to build up. Right, so basic concept, let us start with. Now in this basic concept, first I would say that you should know the meaning of these terms. So let me like terminology. Okay, this terminology you should be very clear about. Number one, something called atomic mass. You should know very well what is atomic mass, what is the meaning of atomic mass. Okay, second that you should know is something called gram atomic mass, and write GAM, gram atomic mass. This atomic mass, and write AM. Right. Third is something called molar mass. Molar mass. Okay. Fourth is something called molecular mass. Like atomic mass, you have molecular mass. Okay. Let me call this as MM. Fifth is there's something called gram molecular mass. Okay, GMM, gram molecular mass. Sixth is again molar mass, but this is molar mass of molecule. Okay. Then seventh is something called RAM, RAM. Now this RAM is relative atomic mass. Okay. This is what you should know. Eighth one is something called relative molecular mass, RMM. Relative molecular mass. Okay. Now these are the 8 terms that you should understand, and you should not only understand, you should have the clarity of these concepts. Okay. So let me start with this, and let me tell you, this relative atomic mass is represented in your IGCSE textbooks as AR. This relative molecular mass is denoted or represented by something called MR. Okay, AR and MR. Okay. Apart from this, you should also understand something called mole concept. Okay, and you should be able to connect this mole with mass, volume, and concentration. Okay, so these are all the things which you should first understand properly, separately as a concept, and then you have to combinedly use all these concepts to understand stoichiometry, how it works. Okay, so our next step will be to understand these concepts. So let us proceed with atomic mass. Okay, now the atomic mass concept, I'll try to explain you this way. Now in the periodic table, okay, or even otherwise in your any of your chemistry textbooks, you always see a symbol or a sign, something like this, X. Okay, there's an A on the top and there's Z over here. Okay, right, this is nothing but the symbol of an element, isn't it? In periodic table you have some 118 elements so far, and you will see various symbols, okay, which are representing the elements. Each elements have a different symbol. For example, hydrogen will be written something like this, okay, in a square box, right? Then you have helium, which is written this way. Okay, 2 and then 4, right? Then oxygen, right? These are elements, oxygen, and here there's some number written over here, maybe 8, and here there's 16. We have carbon, okay, like 6 and 12, okay, and so on and so forth. So these are all the elements, and you can see two numbers, one at the bottom, one on the top. So the bottom numbers, these numbers, okay, these are nothing but the atomic number. These are atomic numbers. Okay. These letters H, He, O, C, these are nothing but the symbols of the elements. So S stands for hydrogen, He stands for helium, O stands for oxygen, C stands for carbon, and so on and so forth. In general, this X is nothing but a symbol of an element, right? Symbol of an element. Now the numbers at the foot of this symbol, is representing Z, which is atomic number. So you can see for hydrogen, the atomic number of hydrogen is 1, and for helium, it is 2, and for oxygen, it is 8, for carbon, it is 6. Okay, so the Z values for hydrogen, helium, oxygen, carbon are given at the bottom, right? Same way on the top, the numbers which are given are telling you about atomic mass number or atomic mass. Okay, atomic mass. Now these are telling you the atomic mass. Now in the first case, hydrogen has an atomic mass of 1. I'm sorry, it should be 1. Then helium has an atomic mass of 4. And oxygen has an atomic mass of 16, and carbon has an atomic mass of 12, right? So these are some examples. In the periodic table, you have so many elements. So each and every element will have such symbol, and at the bottom of the symbol, you will have atomic number. At the top, you will have atomic mass number. So our first term was something called atomic mass, which we have to start with, isn't it? Atomic mass. Can you see here? Atomic mass, right? This one. Atomic mass. Okay? Fine. So, as I told you, hydrogen has atomic mass equal to 1. Now, don't just say 1. In the symbol, it was written 1, but this has to be read as A1 AMU. AMU stands for atomic mass unit. Okay? Atomic mass unit. This one is representing the mass of one atom. Okay, so it's a small atom, even otherwise it's so small. So its mass will also be a very small quantity, and this 1 AMU is the atomic mass of hydrogen. But if you see carbon, then it has an atomic mass equal to 12, and write AMU because AMU stands for atomic mass unit. Okay, so whenever you talk about atomic mass, okay, you have to give the answer as some numerical value followed by AMU. Okay. So in general, atomic mass will be equal to X AMU, where AMU is atomic mass unit. Is that clear? Okay. Now, let us take some few examples. Carbon, oxygen, nitrogen, and one more. Yeah, sodium. Fine. So these are the 4 elements that I'm going to talk about, right? So carbon has a atomic mass of 12. Okay, now atomic mass is something which is written at the bottom of that symbol. I told you this is an element here. Sorry, at the top. Okay, So at the top, this is the atomic mass, right? So carbon will be 12, oxygen will be 16, nitrogen is 14, and sodium is 23. Okay, you can verify, you can check with your periodic table, it will be like that only. So these are atomic mass, right? Atomic mass. And as I told you, don't write just number. Okay, you have to write 12 AMU, 16 AMU, 14 AMU, 23 AMU. Okay, so you have understood what is the meaning of atomic mass, okay, of an element. So it will be in general X AMU. Now, next is uh, gram atomic mass. This one. Okay. Now, what is gram atomic mass? Let me tell you that. Uh, gram atomic mass is atomic mass expressed in grams is called gram atomic mass, right? For example, gram atomic mass for carbon will be 12, and now you don't write AMU, write 12 gram. For oxygen, gram atomic mass will be same atomic mass 16 but expressed in grams, so 16 gram. For nitrogen, 14 gram. For sodium, 23 grams. Is that clear? So this is gram atomic mass, right? Okay, so atomic mass will always be written in the, the unit will be AMU. For gram atomic mass, the unit will be gram. Is that clear? So let me write that gram atomic mass is equal to X gram. Got it? Fine. Now, next in line is something called molar mass of atom. Can you see this third concept? Molar mass of atom, right? So, molar mass. Now, right now, I'm just going to give you a superficial idea of all these terms, okay? Then I will be going in deep and explaining you more about these terms once again. So we will revisit these terms, okay, in future videos, okay, where I'll be explaining you more in detail. Right now, I'm just giving you a superficial understanding of these terms. So molar mass. Molar mass is nothing but same as gram atomic mass. So just write this also as X gram. Okay? This is something known as molar mass. If you want definition of molar mass is the mass of 1 mole of atoms. Okay, so this molar mass is nothing but the mass of 1 mole of atoms, right? So now we will understand that this mole is something that you should know. Okay, so okay, I'll do one thing. I'll change my strategy. Instead of going further, okay, with these other terms, here only I'll try to explain you certain things. Okay, so because now you have come across the word mole, okay, let me tell you what is the meaning of mole. Okay, so mole means what? Okay, so see, you must have heard about this word dozen. Okay, dozen means what? Dozen means 12. Any item which is 12 in number is known as dozen. Suppose you say 1 dozen of books, that means 12 books. 1 dozen of cricket ball means 12 cricket balls. Okay, 1 dozen apple means 12 apples. Okay, so dozen stands for a number which is equal to 12. Right, you must have heard about this pair. Pair means 2. Okay, so whenever we talk about a pair of chappal means 2 chappals. Pair of shoes means 2 shoes. A pair of cloth. Okay, so two clothes. Okay, I mean one pant and a shirt, something like that. So pair means two, right? Same way, mole is representing a bunch of 6.022 into 10 raised to 23. This many, it's a huge number, right? 6.022 times 10 raised to 23 is a huge number. And this mole is used for very small particles like atoms, like molecules, okay, like ions, okay. So these particles are so small that if you take 6.022 into 10 raised to 23 atoms, okay, that bunch, okay, so this many atoms, suppose this is a bag which contains, this is a container which contains 6.022 into 10 raised to 23 atoms, then this quantity is known as 1 mole of atoms, right? Same way, if you have 6.022 into 10 raised to 23, this is the number, okay, of say molecules, say water molecules, okay. Suppose somebody says that I have in this container, okay, 6.022 multiplied by 10 raised to 23 molecules of water, okay. So the meaning of this is he is trying to tell you that he has 1 mole of water. Now you understand? So 1 mole is a name given to this many numbers, 6.022 into 10 raised to 23. Okay. For example, 6.022 into 10 raised to 23 tables, okay, or chair, can be said to be as 1 mole of table or chair. It's a hypothetical just to make you understand. Okay. So this number, okay, of any species is known as 1 mole. Right. So the definition of 1 mole will be 1 mole, okay, is equivalent to 6.022 into 10 raised to 23 species. Okay, now in species, you know, in chemistry, this species means either atoms or molecules, or you can say ions, or any other species, okay, any other particle, right? So this is the meaning of mole. Is that clear? Now let me tell you, mole is bigger than a single atom. Obviously, one atom will have some mass which is known as atomic mass of that atom, but 1 mole is not a single atom. It is 6.022 multiplied by 10 raised to 23. It's a huge number. So many atoms when you take together, then the mass of that particular bunch of 6.022 into 10 raised to 23 atoms, the mass of that much atoms will be called as molar mass. So basically molar mass is what? It is the mass of 1 mole of a substance. Okay, you can call it substance, you can call it species, you can call it atoms, molecules, whatever it is. Okay. Now we understand the meaning of molar mass. So molar mass can be x gram. Okay. Now obviously this molar mass will be a bigger number compared to the atomic mass, isn't it? So now that you have understood the meaning of molar mass also, and all this I was talking with respect to atoms. Now quickly I am going to tell you, give you some examples, and I had already discussed those examples. Which were those examples? Yeah, please. This. Okay. Carbon, oxygen, nitrogen, and sodium. Okay. Now let me tell you how this you have to understand. Okay. So starting with carbon. Okay. Now carbon atom you must have studied in your earlier class. Now this is for the 10th grade, so in the 9th, 8th, 7th, you must have studied about carbon atom. So carbon atom consists of a nucleus which has, in this nucleus, you have 6 protons and you have 6 neutrons, right? And then surrounding this nucleus, you have certain orbits, and in this orbit for carbon, you have some 6 electrons. Okay, 1, 2, 3, 4, 5, 6. Okay, so electrons is how much? 6, right? This is one carbon. Second, let us talk about oxygen. Oxygen also, in the nucleus of the oxygen, okay, you have 8 protons and you have 8 neutrons. Okay, this is the nucleus, right? And the electrons will also be 8. Okay, electrons will also be 8, and those will be orbiting around the nucleus. So in the first orbit there will be 2, in the second there will be 6, right? 6 and 2, 8. So this is what in nitrogen. Okay, in the nucleus of the nitrogen you have 7 protons and 7 neutrons, and of course electron is also 7. So these 3 examples I will take to make you understand what is the meaning of atomic mass. Okay, so carbon, oxygen and nitrogen, all 3 are elements. These are single atoms. So if you take one atom of carbon, inside the nucleus of that carbon, one carbon atom, you will have this 6 protons and 6 neutrons. Okay, so the mass of the carbon atom, one carbon atom mass, okay, will be equal to the mass of this 6 proton and 6 neutron. Why not electrons? Because electrons are very, very small in mass compared to protons and neutrons. Okay, so it is negligible. You can neglect it. You don't consider it. Okay, so electron is not considered for mass. So mass is totally the proton and the neutrons only. Okay, so one carbon means the mass of 6 proton and 6 neutron. Okay, so this is known as atomic mass of carbon, right? Okay, same way for one oxygen atom. Okay, in oxygen atom you have 8 protons and neutrons. So 8 protons plus 8 neutrons, if you total the mass of these two, that will be written as the atomic mass of oxygen. Same way for nitrogen, one atom of nitrogen, one atom, I'm talking about one nitrogen atom, it will have 7 protons and 7 neutrons. Okay, so atomic mass of nitrogen is that much. Now let us see how much it is. Now normally I'll give you one more information. Mass of a proton, okay, whether it is in carbon, nitrogen, oxygen, any element. So mass of one proton is 1.67 times 10 raised to minus 24 grams, right? Mass of one electron is 9.1 times 10 raised to minus 27 grams. Okay, and the mass of a neutron is same as proton, 1.67 into 10 raised to minus 24 grams. Okay, can you see this is 10 raised to minus 24? So it is very, very, very small. The mass is very small for proton as well as neutron. So the mass of the proton and mass of the neutron is similar, I mean same. So what will be the atomic mass of carbon? So atomic mass of carbon, since electron we are not considering for mass, so atomic mass, okay, of carbon is equal to 6 times 1.67 into 10 raised to minus 24 grams plus another 6 times into 1.67 into 10 raised to minus 24 grams, right? Now why I have repeated 6 2 times? Because these are 6 protons and these are 6 neutrons. Now mathematically this will be 12 times 1.67 into 10 raised to minus 24 grams. Am I right? So this is the mass of a carbon atom. This is the mass of one carbon atom. Now, this particular thing, 1.67 into 10 raised to minus 24 gram, 1.67 into 10 raised to minus 24 grams is a quantity which in chemistry is known as 1 atomic mass unit, 1 AMU. Did you get me? This quantity, 1.67 into 10 raised to minus 24 grams, is called as 1 AMU. So can I call this as 12, and instead of this I am writing AMU. Okay. So what I mean to say is the mass of the atomic mass of one carbon atom, the atomic mass of one carbon atom, single carbon atom, is how much? 12 AMU. Okay, it is 12 AMU. Or you can say 12 into 1.67 into 10 raised to minus 24 grams, right? And there's not a much difference. Okay, this will work out to 12 grams. Okay, if you want to say gram atomic mass of carbon. So gram atomic mass of one carbon is what? Atomic mass expressed in grams. So 12, remove AMU and write just G. So what is gram atomic mass of one carbon? It is 12 gram. Now it is not actually 12 gram. This is rounded figure that I am writing. Okay. But every time for gram atomic mass of any element, you know, whatever is the atomic mass in terms of AMU, you just remove that AMU part, the unit you remove, keep the numerical value same, and substitute that AMU by gram. That will give you gram atomic mass. Okay? But it's not like that. I'll tell you how it works. Now, gram atomic mass is what you know. Gram atomic mass is atomic mass expressed in grams. So it is actually 12 into 1.67 into 10 raised to minus 24 grams. Okay. Now this, when you express in grams, it will come to 12 grams. Okay. The third one is something called molar mass. And I told you molar mass of carbon. Okay. And I told you molar mass is nothing but mass of 1 mole of carbon, right? So mass of, if you take just one carbon atom, and if you try to find out the mass, it will be 12 AMU. But if you take some 6.022 into 10 raised to 23, this many, if you take carbon atoms, okay, this many carbon atoms, it will become a huge amount. Okay, and if you find out the mass of this, you know, you will call it as 1 mole of carbon. So let us see how much is 1 mole of carbon. So 1 mole of carbon will be how much? Now see, 1 atom of carbon weighs 12 into 1.67 into 10 raised to minus 24 grams, right? This is the mass of one carbon atom. But if you take 6.02 into 10 raised to 23, so if you multiply this by 6.02 into 10 raised to 23, then this calculation, this total will give you the mass of 1 mole. So mass of 1 mole of carbon will be atomic mass, that is mass of one atom of carbon, multiplied by 6.022 into 10 raised to 23. Now if you use your calculator, if you multiply this 1.67 by 6.022, you will get the answer as 10. Okay, you can try if you want. 1.67 into 6.022, you will get the answer as 10. Okay, then this 12 is also there, so you can write that 12 over here. 12 into 1.67 into 6.022 is 10, and this 10 raised to minus 24 times 10 raised to 23 will be 10 raised to minus 1. Am I right? So 10 raised to minus 1 and this 10 raised to 1, they will nullify each other. Okay, it will become 10 raised to 0, which is 1. So you are left with only 12. So 1 mole of carbon is how much? 12 grams. So this gram was over here. Okay. Did you understand? So 1 mole of carbon works out to 12 grams. Is that clear? Now try to understand. One atom of carbon has a very small weight, that is 1 AMU. In terms of gram, it will be 1.67 into 10 raised to minus 24 grams. But if you take a bunch of 6.022 into 10 raised to 23 atoms of carbon together, then the number of carbon atoms will be increasing. So mass will also be increasing. And that mass will you will be calling it as 1 mole of carbon. Okay, 1 mole means it is not one atom of carbon, but many atoms. Many means how many? 6.023. In fact, this number 6.022 into 10 raised to 23 is known as something called Avogadro's number. Avogadro's number. This is the name of the scientist who invented this Avogadro's number, and it is represented by Na. Okay, this is how you represent this Avogadro's number. So Na is nothing in chemistry but a number which is written as 6.022 into 10 raised to 23. This is Avogadro's number, a very important number in chemistry, right? So Avogadro's number is 6.022 into 10 raised to 23, and 1 mole of carbon means 6.022 into 10 raised to 23 atoms of carbon, or you can say Avogadro number of carbon atoms, and that will weigh how much? 12 grams. 12 gram is a little big value compared to 1.67 into 10 raised to minus 24 gram. Okay, so this is the mass of one atom of carbon, which is known as atomic mass, and this 12 gram is the mass of 1 mole of carbon. 1 mole of carbon means 6.022 into 10 raised to 23 atoms taken together will give you 12 grams. Okay, so I am very slowly, very nicely making you understand this chemistry concept, so that I'll be going slow, I'll be going more in detail. Okay, but you will understand things very nicely. But then you should not just hear to this listen to this video, or you have to read also alongside. Okay, so these are the concepts. The clarity that I am giving you is of the concepts, but when you practice and when you read from the textbook, once you understand the concept, you will understand what is written in the textbook very nicely. So this being the first video on stoichiometry, I will end today's video here only. In the second video, I'll continue from where I've stopped today. Okay, bye.